Hi, here we have a couple of sample problems that involve pH and how to use your calculators for it, and also a bit how to navigate around using, the various tools that we have learned. Now, in this case, the question is, what is the pH of a solution of sodium hydroxide? Okay, and they give us a concentration of sodium hydroxide. Now, there is something that hopefully you have. It's a little tool that I call an acid-base map. Now, what this basically does is, depending on where you're starting, what information they give you, and what the information the question is asking, you can use this in order to kind of navigate about. For example, this question is asking, what is the pH? So in a way, we're trying to find the pH. And the information that they're giving in this case is the concentration of NaOH. That's our starting point, and we're trying to figure out what the pH is. Now, this is a strong base. It's a alkali metal with hydroxide, so it's a strong base. Now, I'm going to be starting on this island, and I'm going to be going to pH way over here. Now, that means I'm going to have three basic steps that I'm going to need to do this problem. The first one is the easiest, and that is, hey, look, this is a strong base, and therefore its concentration of hydroxide is going to be the same, especially since there's only one hydroxide here. Therefore, these two are going to be equal to each other. So I know first step is that the concentration of NaOH, which is equal to 0.25 molar, is going to be the concentration of OH negative. So there's my first step. I now have the concentration of OH negative. Now I want to go and get to hydronium. That way I can use the pH, the log to find pH. So to get from hydroxide to hydronium, I'm going to use the Kw equation right here and know that, well, hydronium is equal to Kw over the concentration of hydroxide, okay? So Kw is 1 times 10 negative 14. OH in this case is 0.25. Therefore, on my calculator, I go 1 EE negative 14 divided by 0.25 equals. And I have 4 times 10 to the negative 14. Now, for significant figures purposes, remember this is a constant, and don't worry about that. I have 2 here, so technically that needs to be 4.0. All right, 4.0. Let me erase that, make that nice and clear. 4.0 times 10 to the negative 4.0 times 10 to the negative 14. Sorry about the bell. And then this is concentration. Again, that's a concentration of hydroxide. And then the last step is, in order to find the pH going in this direction, I take the negative log of the hydroxide. So I have that, which is 4.0 times 10 negative 14, and I want to take the negative log of it. So the way I do it is this. All right. I go, if you see right here on the log button, all right, it has a 10 to the x as the inverse. So I go negative, all right, remember it's negative. So I go the negative button down here. So clear that. Negative. And then second, sorry, not second, I just go log. It's not 10 to the x, sorry. It's log, so negative log, and then the concentration of that answer. So I'm going to go second answer, which is 4 times 10 negative 14. I push equals. Now, since this question this has two significant figures, all right, the pH, again, is equal to the negative log of the concentration of H3O, which is the negative log of 4.0 times 10 negative 14, okay? And therefore, since that has 2 digits, I need to go 2 places past the decimal. So the pH is equal to 1.3, and since that's a 9 after the second 3, I round it off, 1.34. And there's my answer. Now remember, with pH, there are no units, all right? No units. So that's the first sample problem. The second sample problem is kind of going in reverse. Here, it's telling me what the pH is, and it's asking what is the hydroxide ion concentration. So I'm starting with pH, and I'm trying to go to OH negative. Now, looking on my map, I see that, well, if I'm starting here on pH and I'm going to OH, it's going to be a two-step process. The first is to use the pH in order to get to hydronium, and then use Kw to get to hydroxide. So, first step is I'm going to want the pH, excuse me, my mistake. I'm going to want, I have the pH, it's going to be the concentration of hydronium is equal to 10 to the negative pH. So that's going to be 10 to the negative, all right, sorry, not molar, it says 3.4. Saw that, I was going, what's wrong with that? So the pH is 3.4, so it's going to be 3.4. So on my calculator, I go second, 10 to the x, negative 3.4 equals. Now here, I have 3.98. Now, I have one place past the decimal on my pH, so that means I only have one significant figure on my answer here. So I round it off to one digit. It is simply 4 times 10 to the negative 4 concentration. Remember, that is equal to the hydronium ion. My last step, now that I have hydronium, I'm trying to get hydroxide. I use the Kw equation to find the hydroxide. And remember, since Kw is equal to hydronium times hydroxide, if I want to find hydroxide, I would divide both sides by hydronium. Okay? And therefore, those cancel out. Hydroxide is equal to Kw over the concentration of hydronium. And therefore, I have 1 times 10 negative 14 divided by 4 times 10 negative 4. And according to my calculator, I have 1 EE negative 14 divided by 4 EE negative 4. And I get, as my concentration of hydroxide, 2.5, well, I have to round that off, so that's going to be 3, right? Because that only has one digit there, 3 times 10 negative 11 molar. And there's my concentration of hydroxide.